Problem B5. The 11-digit number, as shown, is divisible by exactly 8 of the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. Find the values of A and B, explaining why they must have these values. So the number is A, 1, 2, 3, 4, 5, 6, 7, 8, 9, B. Now, let's see what numbers it has to be divisible by, right? So 1 it has to be divisible by, so we can ignore that. Because one of the numbers is not going to be divisible by this 11-digit number, right? Because 8 out of 9. 2, it has to be divisible by 2. Why? If it's not divisible by 2, oops, it's not erasing. If it's not divisible by 2, it's not also divisible by 4 or 8 or in fact 6. And that's not possible, so 2 has to be one of them. Also, this applies to 4, because if 4 is not divisible, if it's not divisible by 4, it's not divisible by 8. So, we can rule out the options 2 and 4 because they have to be divisible. Now, if it's not divisible by 3, it's not divisible by 6, and that's going to be bad again, right? Therefore, we have literally just ruled out all of that. Yep. Now, since we already know it's divisible by 2 and 3 from before, it is also have to be divisible by 6. Right? Now, since it's divisible by 3 and 6, it has to be divisible by 9. So we're left with 5, 7, 8 to choose from. Let's just say, I don't know. It's divisible by 8, not 5. Okay? Because 8 and 5 are the main arguers. 5 ends in a 0 or a 5, and 8 ends in even digits, right? So that's a big argument, so I'm going to start with that. So 8, if it's divisible by 8 and it's not divisible by 5, let's assume. Now we're going to write this number out with the two front gaps, the two gaps, front and back. For a number to be divisible by 8, right, it has to have the last 3 digits a multiple of 8. Currently it's 8, 9. The only possible digit is 896. If you divide that, what do you get? Let me just do this right now very quickly. Sorry, I have a cough. Now this is 1, and now that's 0, 9, 1 again, and then, whoopsie, says an 8, 16, 112, boom, divisible. So, we know that we can put a 6 here. Now, what can A be? So, what can A be? Well, it has to be divisible by, 3 and 6 and 9. Right? Now, how do we make sure it's divisible by 6? Well, if it's divisible by 3 and it's divisible by 9, if it's divisible by 3 and 2, that's fine, right? And it's already divisible by 2. Now we have to find a number that makes this divisible by 9. Because if it's divisible by 9, it's also divisible by 3. Now, the divisibility rule of 9 is the digits sum to 9, a multiple of 9. So if we just take that, the sum is going to be 51. The closest multiple of 9 is indeed 54. So we put a 3 here, because that's add 3. And that is our number. But is it divisible by 7? That's our last check. If this goes, then we put the answer, if it works out. Now if we just, I'm going to do this division. So I'm going to try and kind of do it in my head-ish. Actually, I'm just gonna use normal division. So that's 4. Then it goes in. Then I think it's like that. Yeah. Okay. So it actually does go in. And if you do try the calculation, well, if you don't believe me, you can get a calculator. But I'm going to go to browser, right? And then I'm gonna search calculator, in the actual exam, you're not going to be doing this calculation. You're not going to be using a calculator, but here I'm just saving time. 4, 5, 6, 7, 8, 9, 6 divided by 7. Yep, and that is correct. It is divisible. Right, so we are going to proceed to conclude our answer. A has to be equal to 3 and B has to be equal to 6. Because if you were to have something divisible by 5, it will not be divisible by 8. And therefore, then, well, it could be, but then the only option is for this to be 5 or 0, the last digit, right? But that's clearly not divisible by 7, so we can delete that answer out. And we have proven it, and that is our final answer. A equals to 3 and B equals to 6. Sorry about this color.